Hey folks, today's topic is calculator mistakes. So some of this will feel like review, but I just want to talk about some of the features. I'm going to focus on the TI-84 Plus, and I have the new operating system on here. You can tell if you have the new operating system is when you hit the, let's say, to the button. If you get an answer to the, that's the new operating system. The old operating system will look like this when you hit to the. And so you have to use a little bit more parentheses in this case, where this you don't have to use as many parentheses because it keeps it up in that exponent. But you've got to be careful because you got to come down. We'll talk more about that. But just know which operating system you have. And if you have an 84, I can upload the new operating system if you like that one better, which I would recommend. It is nicer. So today's topic, we're going to go through some of the mistakes that people make when they use their calculator, because I don't want you to get something wrong just because you didn't know how to use this great tool that we have known as our Graphing Calc. All right, so let's talk first about the order of operations. I'm going to refer to the order of operations as a house. Now this house has 3 floors, and it has an attic. Or a penthouse, I guess, depending on how you look at it. I guess it's probably the penthouse because of how powerful it is at the top. So the order of operations house, the simplest operations start at the bottom. Now you guys probably remember from elementary school something like this. Now that still works, but you've got to be a little bit careful. And remember, this stands for, please excuse my dear Aunt Sally, is the way I learned it. This stands for parentheses, exponents, multiplication, division, and addition, and subtraction. But we have to be a little bit careful because multiplication does not always come before division, and addition does not always come before subtraction. So whether you remember that or not, I'll go over it again. But this is how I'm going to describe the order of operations. I'm going to talk about the easiest operations are the operations at the bottom of the house. I mean, they're the easiest level to get in. So if you think about it, what was the first thing we learned after we learned how to count? We learned how to add. And then who do we learn after that? Subtract. Now, it makes sense to put these two operations at the same level because they're really the same operation from a different perspective. Addition and subtraction, I can turn an addition problem into a subtraction problem very easily, right? Let's say 10 subtract 3. I could turn that into an addition problem by saying 10 plus negative 3. And so these are basically interchangeable operations. They're inverses. They're really the same operation from a different perspective. Next up, the next most complicated, after you learned addition and subtraction, you learned how to multiply and its inverse, divide. Those are really the same operation. If I wanted to take 10 and divide it by 2, I could turn that into a multiply problem. 10 divided by 2 is 5, or 10 multiplied by 1/2 is also 5. So it's easy to flip back and forth between those two operations. And then the top level, exponents, and this is why I like the house better than I like please excuse my dear Aunt Sally, because this does not include the inverse of exponents. Exponents inverse, roots. So if I wanted to kill a squared, we'd kill that with a square root. If we wanted to kill a cubed, we'd kill that with a cube root, a fifth with a fifth root, and so on. And then finally, the only one that's created by human beings, this is the one, if you went to any planet, they would have to do the order of operations in this order. And I'll talk more about that in this space. But the one that human beings made up is parentheses. Parentheses, some person said, parentheses, these brackets mean, these curvy things mean do whatever's inside of that first. So let's talk a little bit about how we use the order of operations house. We want to do we always start at the top and work our way down. So the strongest for instance, if you had a problem that had exponents in it and it also had division, you'd have to do the exponents before division. But looking at it from the perspective of what happens if you have multiplication and division in the same problem, that's what I was talking about with the please excuse my dear Aunt Sally. This does not have a direction. It's whatever comes first, whichever comes first, left to right. So whatever shows up first in the problem is what you would then do first as you evaluated it. And let's talk a little bit, why are the exponents, why do you have to do exponents before multiplication? So why exponents before mult? So that's the question. Well, let's think about what exponents really are. Let's take something like 2 to the third. 2 to the third really means, I know it's 8, but what does it mean? If you're trying to teach somebody why it's 8, I would think you'd say something like, well, 2 to the third means 2 times 2 times 2. So 2 times 2 times 2, all of a sudden this exponent thing just became what operation? It just became multiplication. So exponents are really hidden mult. That's why you have to do exponents before multiplication, because exponents are hidden multiplication. So then the next logical question would be, why mult before addition? Well, using the same kind of argument, I would say, what's 2 times 3? I know you know it's 6, but if you're trying to teach somebody how to do this, you might say, well, 2 times 3 means do 2 3 times. So 2 plus 2 plus 2. So what is multiplication? Multiplication is really hidden addition. So you have to do all the hidden operations before you do the actual operations. So human beings said do parentheses first, so we're stuck with that one. But from there on out, like if you went to another planet and you had a problem that had exponents and multiplication in the same one, you'd have to do exponents first. So would they. Otherwise, math is, that part of math is universal. So you might see this on Facebook once in a while, or whatever is the popular app at this time. But you might see something like this: 3 subtract 5 times 2 plus 1. And they might say, hey, what's the answer to that? And you get in a big argument. Some people are saying it's one answer. And no, you follow the order of operations. This is it. So whatever the most powerful operation is, you do that part first. So I would do multiplication first, because that's higher than the subtract and the add. So I would have 3 subtract, what's 5 times 2? That's 10, plus 1. And now I would go again according to the order of operations. I have a subtract and I have an add. They're the same strength, so whichever one comes first from left to right. 3 take away 10 is -7. -7 plus 1 is -6. There is no ambiguity there. It only feels ambiguous because people don't know their order of operations. So you maybe see this on Facebook. And now you know what the answer is, and some smart aleck try to talk you out of it, and you say, no, this is how the order of operations work. All right, so what's nice about our calculator is we don't have to tell our calculator to do the order of operations. The person who, the engineers who programmed it told it to do the order of operations for us. So we didn't have to tell it to do 5 times 2 first. It knew to do the order of operations. It gives us the same answer. So you don't have to do much by hand if you don't want to. Most of the stuff we'll be able to do is on the calculator. So I want to show you some of those tricks on the calculator. The first trick is how to use the answer button or the store button. So let's start off. Let's evaluate -2 times 3 plus square root of 5. So -2 times 3 plus, now square root is above squared. So there's the squared button. And for me to get the buttons above a button, I either have to hit blue or green. Now maybe your colors are different, but whatever the print is, I want the square root, which is in blue. So I'm going to hit the blue button first, and then it'll give me the square root of 5. And I get this decimal. Now, if you don't have fancy calc, you would have something, yours would look like this, -2 times 3 plus square root, and it automatically gives you a parenthesis, which then you just need to close that parenthesis afterward. You get the same answer as we got, -7 point blah, blah, blah. Okay, so in this class, I expect you to round properly to 1 or 2 decimal places. 1 or 2 decimal places. I don't care which, you can pick, but you have to round properly. In this case, if I'm rounding to 1 decimal point, that means I look at the 7 and I look at the number next to it. That's a 6, so that would round that up to an 8. I like to round to 2 decimal points. So I ignore the 7, I look at the 6, and then I look at the number next to that. I don't care that this is a 9 to round that. No, you pick one number and you round it. So I'm looking at the 6. The number next to that is a 3. The rule is 5 or above rounds up. 4 or below, leave it. So I don't round this down to 0.75. It'll never go down. It could go up to 0.77. But because that's a 3, I'm going to leave that, so I would have -3.76. Okay, now the point of this answer button, if you look down below, this is 4 times that chunk that we just had, minus 3 times that chunk squared. Now you can go ahead and type this all in if you want to, or you can use the answer feature. So the answer feature takes whatever your last answer it was, and it stores it as this button down here above the negative called answer. So now I'm going to do 4 times, now this was our last answer, so second answer, close it, then minus 3 times, it's going to take that answer button again, squared, oops, and we get -55. Okay, let's round this one properly. -57.5. I want to round to that one, so I look at the 7 is going to round that up. -57.56. Now, the other way you can do this, especially those of you who are going on to AP, we do this move a lot. We do the store. So now I'm going to go back. I'm going to bring back up what I had before, or type it back in. So this is what I'm going to get. Now I'm going to store that. So I'm going to hit, if you look here, STO arrow means store. So when you hit store, it'll say answer, which means it's going to take that answer and it's going to save it. And now we're going to pick one of these letters. You can pick any letter that you want, but to select the letters, those are in green. So I'm going to hit the alpha button first and then the A. And now that's A is now stored as this. Some of you maybe already did this in chemistry for Avogadro's number. But anyway, so for us, this whole thing is now worth A. This whole thing is now worth A. So when I type it into my calc, it's going to be 4 times A. You could use parentheses or not, it's up to you. 3 times A and then a squared. Now this should give us the -57.56 that we got before, and there it goes. So I don't care which way you do it. Answer sometimes is slicker. Probably you're going to use answer a lot more than you're going to use store. But if you need to use that answer over and over again, store it as a variable, and then you can use it in all sorts of different equations. Okay, so I kind of did it on here already. Let's talk about how to do second enter, insert, and delete versus clear. So clear is real easy. When I want to clear something, I just hit clear and it deletes the whole thing. But what if I don't want to clear anything, but I want to just get rid of a certain piece? So we'll talk about that. Okay, so first of all, plug and chug. It's a little too bright, I think. Let's try this. Okay. So I want to do the square root of 5 plus, I'll clear out the old stuff. Square root of 5 plus 14. Subtract the quantity of 8 times 3 subtract 24 to the fourth. Type all that in, we get 4.35, the 3/6, so we got to round properly. This turns out to be 4.36. I don't really care what that answer is. The point of this example is to talk about how to go and just edit a small portion of what you already typed in. Now look, you can just retype this again if you want to, feel free. You can do that, but you can save yourself some time by choosing second and then hitting the answer button. Second and enter, second, enter, brings up exactly what you typed in before, and now you can go back and you can edit it however you want. Okay, so they want us to put a -5 in there. So if I go to the 5, your calculator is set up to overwrite. So don't do this. You can just watch, though. If you hit negative right now, it'll take away the 5 and overwrite it with a negative. And then you got to hit the plus, the 5, and now it deleted the plus. So instead of doing that, I'm going to bring up what we had before, and I'm going to insert a negative in front of the 5. So I'm going to insert. Insert is above delete. It's blue, so I got to hit the blue button first. Insert, and I want to slide a negative in there. Now it's taken everything and inserted the negative and has slid everything else down. Now we can calculate, ends up being a 3. So that was two things that we talked about there, insert, and then we talked about, or second enter first, and then we talked about insert. All right, in this next one, let's go back. Now this one is, which one of these two do you think this is closer to? And it's not going to save a ton of time in this case, but I'm just trying to pick an example that made you go back. What if you wanted to go back? I would argue that I don't want to use the one I just typed in because that's got that negative, and I'd have to push all the way up to the front, delete that, and change the 24 to a 23. I want to go back to this one and just change the 24 to a 23. So now I can go second, enter, and then hit second, enter again, and it'll bring up what you typed in before. Every time you hit second, enter, it just, remember that stuff that we typed in? Remember when we stored things? It just keeps going, and it takes whatever you typed in the time before. So now I'm all messed up. I'm out of order here, so I got to find the one that I want. No, I don't want that one. I don't want that one. So I got to keep going back, second, enter, until I find there's the one that I wanted. That looks just like this. So now I want to take this. I like the root. I just want to make the 24 a 23. Now, in this case, I don't want to insert. You could, but I'm happy with just hitting 3, and it makes it into the 4 into a 3. Now, let's say that you did insert. Let's say you go here and you insert the 3. Now, to get rid of the 4, you don't want to hit clear. If you hit clear, everything's gone. We've all done that before, I'm sure. Okay, now I got to find it again. Give me a sec here. Okay, so if I insert the 3 and then I need to get rid of the 4, I want to delete, not clear. So if I hit clear, it'd get rid of the whole thing. If I hit delete, it only deletes the 4 and leaves everything else in there. And we get what? 3.3. You round that correctly. 3.36. Okay, so hopefully that shows you second insert brings up what we had before. Insert slides everything down. It inserts it and slides everything else down. And then delete only kills off one term at a time. So let's say I wanted to make this 5 plus 4. I would do second enter. I would push back until I got to the 1. I would hit delete. And now it's just 5 plus 4. And, get a nice answer of 2 there. Oh, yeah, I guess that makes sense. That's 9, square rootable. This is 1, 1 squared. Yeah, 3 take away 1 is 2. Let's talk about how to find roots that aren't just square roots, how to convert back into a fraction, and then how to find the absolute value. So let's start off by trying to do the 5th root of blah, blah, blah. Okay, everything good when you're graphing, and we're going to get more into this in Unit 1, but everything good underneath graphing is underneath calc. So that's trace, and above that is calc. So like you can figure out where your graph crosses the x-axis, the mins, the maxes, where two lines hit each other. These are derivatives and integrals. We'll talk about those for AP. But we aren't trying to graph. We're just trying to find these kind of weird mathematical symbols like absolute value or fifth root. Everything good on this screen is underneath math. If you're graphing, everything good is underneath calc. Those are all the good things. When you're on this screen, everything good is underneath math. Now I've got this option here called 3 root. Now that's just the cube root though. I want to do a fifth root. That's what this stands for. That x is whatever you put in front of that x is going to be your root. So if I hit that option, it gives me the little answer thing. I don't want to put that there. I'm going to clear that out. I'm going to delete that out and put a 5 in there because I want to do the fifth root of negative. Now, because I'm going to power here, I got to make sure I use parentheses to the fourth minus parentheses to the sixth. What do we get? You know what? I'm going to change that. I think I like this problem being just the, let's just do the fifth root of 32. Because I haven't really explained how parentheses work. That's what the back is for. So I'm just going to pick the fifth root. Let's make it a little, let's get a crappier answer. Fifth root of 127. Okay, so let me clear out of here again. So I want to do the fifth root, math, x root. Go up there, and if it says answer, delete that out and put a 5 in there. And then I want to do 127, so 2.63. Now let's say you don't have fancy calc, you don't have fancy operating system. That's okay, it's in the same place. But before I hit math to go find the x root, I'm going to put the 5 in there first. Then math, go select the x root, and it says 5x root. That's taking that 5 and it's putting it right into that spot. What did I do? 127. We get 2.63 again. But that's what it's going to look like if you don't have fancy operating system. Next, I want to talk about how to take something and frac it back. In other words, once you have a decimal, sometimes you can turn that decimal into a nice fraction. I call that frac back. We like to frac it back if we can. So I'm going to do 22.75 divided by 42.25. And that's going to spit back a nasty decimal. And if the answer says just write a decimal, you're good to go. But I want to write this as a simplified fraction, so I want to turn it back into a fraction. Like I said, everything good is underneath math. So select math, and the first thing you see is this arrow frac. That means whatever you put in front of this will turn it back into a fraction. Now I got to hit enter again so that it turns it into a fraction, and we get 7/13. Now, if you don't have fancy calc will write it already as a fraction like that. If you don't have fancy calc, it's fine. 22.75 divided by 42.25, frac back, same place. It just says 7/13 horizontally instead of vertically. And then last is absolute values. Now, if you have fancy calc, absolute values are in 2 places. And actually, going back to this problem, there's a couple nice things about having fancy calc. If you hit alpha and then see F1 right there, alpha F1, you get this thing that says N over D. N stands for numerator, D stands for denominator, and it'll give you the top and the bottom of your fraction. So 22.75 over 42.25. And what's nice about this is it automatically, oh, it didn't do it that time, but if it comes out nice, usually it'll frac it back for you. Didn't do it that time, so I had to frac back on my own. Now let me show you where that was again. Alpha F1. Now there's alpha F2. You see how it says function, matrix, y variable? Alpha F2, that's where my absolute value is. So I can do 22 plus 32 times -5. I'm just getting that from the next example. And it spits back 138. Now, if you forget where that is, just remember Everything good, I'll use the other calc just to show you. Everything good is underneath math. So when I hit math, now I have to, there's no absolute value here. I look through, there's nothing there. But look at the top, it says math, but then these are other categories. When I push over to the next category, there's my absolute value. Now, without the new operating system, that's what your absolute value symbol is going to look like. So you need to close your parentheses, but it still gives me the exact same answer. Math, go over to number. That's what num stands for. If you have fancy calc, it'll put the bars for you. If you don't, it just says ABS. All right, hopefully that made sense on some calculator stuff. Now let's go for the calculator errors. These are the common mistakes that I want you to avoid like the plague. First of all, we've got these things called the variable error. So I'm going to do this as a thought experiment. Evaluate x to the third if x equals -2 and try to do that in your head. Well, all right, -2 cubed would be -2 times -2, which is +4, times another -2 is -8. Now do -2 cubed on your calc. All right. -2 cubed. It's still -8. So far, so good. Yay. Now do x to the fourth if x equals -2 in your head. So that means I'm going to multiply 4 -2's together. -2 times -2, +4. -2 times -2, +4. 4 times 4 is 16. Now let's try that on our calculator. I'm going to use my other calc, just switching it up. -2 to the fourth, and we get, calc says -16. Why? Why did it do that? Because you're not asking the calculator the correct question. There's a difference between -2 to the fourth and -2 to the fourth. Now, in this case, you got to follow the order of operations. Who's the toughest thing in this problem? Well, it kind of feels like that negative should already be attached because it's the number -2. That's not true. There is no number -2. All this means is the opposite of the number 2. There's only positive numbers. And then we have this attachment. That means you go in the opposite direction. So -2 is not really a number. It's the opposite of the number that we know called 2. So according to the order of operations, which is exactly what your calc will do, we'll do the order of operations 100%. What's the toughest thing here? The negative is connected by mul, and the 4 is connected by exponents. So exponents is stronger. So your calc does 2 to the fourth, gets 16, and then attaches the negative and makes it a -16. If we put parentheses around the -2, and then I raise it to the fourth, now who's the strongest operation? Parentheses is the strongest. So that takes the negative and the 2 and connects them together first, and then raises them to the power of 4. So we do get our actual answer, but we've got to type it into the calculator correctly. So what's our big takeaway here? Variable error. Always put parentheses around variables. Now that's not quite true. I mean, you don't really have to do this because notice up here, this turned out to be the same answer. Why did it work here and it didn't work here? Well, think about how many negatives you have. How many negatives does this problem have? It has 3 2's and only 1 negative. How many negatives does this have? It has 3 -2's, so it has 3 negatives. 1 negative or 3 negatives, either case is going to turn out to be negative. That's why you get the same answer. But down here, this has 1 negative and 4 2's, while this has 4 negatives and 4 2's. So this is 4 negatives, which is going to turn into a positive, while this would still be negative. So my advice is to turn everything that's a variable, put parentheses around it, and then you don't have to worry about it. Okay, so let's try this one. I would recommend going through first and trying to parenthesize. So what would that look like? -2. There's a variable, so now I'm going to put that thing in, that variable in parentheses. Cubed minus, there's another variable, -4 to the 4th. Grab my calc. Now I can type this all in, -2 parentheses, -3 to the 3rd. Now that's what kind of stinks about this new fancy operating system. You got to push over to get back down from that exponent. Subtract, then another parenthesis, -4 to the 4th. -202. I guess I didn't mention it, but make sure that you know the difference between a negative and a subtract. In this problem, it's kind of sneaky because these two are the exact same length. But this is a negative, and then this is a subtract. We know it's a negative because there's nothing out in front of it. So context implies that that minus goes with the 2. Because there's something in front of this, this is treated as a subtract, when really, if you wanted to, you could change this to plus or negative. Some middle school teachers sometimes have you guys do it in that order. Okay, next error, fraction error. So let's do 1 plus 3 divided by 2 in our head. So 1 plus 3 is, what color? 1 plus 3 is 4 divided by 2 is 2. All right, we did it. We're the best. Now let's try to do this on our calculator. So I type this into my calculator. I'll use the new operating system. 1 plus 3 divided by 2, and we get 2.5. 2.5. What happened? What's wrong? Well, look, you got to think about what this problem is asking you to do. There's implied parentheses here. It's implied over here. What did we do first? We did 1 plus 3, got 4, then divided by 2. Like I said at the beginning, your calculator will do the order of operations 100%. So plus division, who's tougher? Division is tougher. So your calc will do 3 divided by 2, get 1.5, and then add 1 to that and get 2.5. So if you want to talk to your calculator correctly, we need to put parentheses there. So now if I try this again, 1 plus 3 divided by 2, we do get the answer of 2. So it does work out. We've just got to make sure that when we use, whenever we have a fraction, you must put parentheses around the numerator and denominator. Or if you have fancy calc, remember that alpha F1 N over D allows you to pick a numerator and a denominator. So I can put the 1 plus 3 up there and then the 2, and I don't need parentheses, but you've got to have the new operating system to do it. Okay, let's pretend like you don't have the new operating system. Where would you need to put parentheses in this problem to be able to get the correct answer? Well, I'd have to put parentheses around this denominator and this numerator. You don't have to. You can. You don't have to put parentheses around this because there's only one term. There's only one term. Other kids want to put parentheses around the whole darn thing. They don't want to do it like that. That's fine. You're just over parenthesizing. Your calculator knows to do this division before it does this addition, so you don't need to group this as a fraction. So I'll type this in old school, so I'm not going to use the alpha F1 key. You can if you want to. Minus 36 divided by the group, 14 minus 2, plus the group, 5 minus 6 plus 11, divided by 20. Negative 14.5. Actually, let's frac that back. Negative 29 over 2. A little bit nicer answer. Now you leave it as negative 14.5. That's fine. That's fine. It didn't say we had to write it a certain way. Okay, and then the last type of error called square root error. Let's try to do this in our head. The square root of 16, 4. Plus 10, 14. No problem. Easy peasy, right? Now let's try to do this on our calculator. I'm going to go old school calculator because the new one, you'll never have this problem. Square root of 16 plus 10, and it says it's 5.099. How did that end up? What's wrong with this? Well, you can probably already figure out who's getting square rooted, the 16 and the 10. So if I want to stop the square rooting and then add 10 to that, that'll get me where to go. Now, like I said, you'll never have this problem with Big Kid or fancy operating system, except for one detail. Look at what happened there. When I just kept typing, it stayed under the root, and it will stay under the root as long as you don't push over to get out. You got to push over, and then you're not under the root anymore. So a couple tricks for either style of calculator. So what did we get first? 5.099. Nope. But then when we did it again, we did get the right answer of 14. So what's the takeaway here? What's the hint? The reminder is always put parentheses around everything under the root. Now that has a double implication because if it's not underneath the root, then you don't want to include it under the root. All right, let's see if you can do that last one. Pause. I'm going to use Fancy Calc. So alpha F1 gives me a fraction. Negative 14 plus 3. I've got a variable, so I'm going to put that in parentheses. Negative 2 to the 4th. Now, this is a group on the bottom, but I don't need to parenthesize it because the root will parenthesize it for me. So I'm going to do now a cube root. So math. This time I'm going to just choose the 3. It's a cube root already. 2, another variable. Squared plus another variable. Negative 3 to the 6th. 3.76. I like to round to 2 decimal places. 3.76. All right, so hopefully that was a lot of review, but hopefully you also saw some tricks, especially like the second enter and alpha F1 and F2 to save you some time. Good luck on the homework.